Hello everybody, today we are going to talk about the polymorphism, virtual functions and abstract classes. We'll try to explain the topic by creating a firm. Right, today we are going to create a firm with animal. So let's create a class that will be called animal. Okay, so here we have a class animal, and in the public section we'll create a function that will return the string, and it will be called getVoice. So it will return the voice of an animal, right? And we'll make it in line function. So here we should return the string. Of course, if we are using string, we should include here the IOStream and use the namespace std. In the protected section, because we want to inherit later from the class animal, we'll create a variable that will be called voice, right? And this voice will be assigned inside our constructor, and of course we need also destructor. So here we'll return the voice inline function. We also need to assign that value to that place. So let's define our constructor. So to the voice we should assign what? And this is the question, right? Ask yourself, what should we assign to the voice of animal that we can specify? We don't know if it's a cat, if it's a dog, if it's a cow. We don't know what animal is that, so what voice it has. And here's a problem, because it is some kind of abstract thing, right? It's abstract a bit. We'll talk about it later. Right now, to not make it hard, I will just type here default value, okay? Something like that. Later we'll change it a bit, because I want to show you the problem very clearly. Okay, now I build and run that program. As you can see, everything works fine. So far I have written everything fine. Now let's create that animal. I need animal, right? And let's send to the output animal get voice. Let's see if it works. And as you can see, everything works fine. Okay. Now I want to create classes that will be representing animals, like for example dog, and this thing will inherit the public way from animal, right? So right now I have just copied everything from here because we don't have private section here, right? Well, we don't have anything in private section because private section is here, right? By default, here is something like private, but we have just inherited everything in dog. Okay, we'll create just to make more examples. Dog and cat, and for example cow, right? We have 3 animals, and now we can specify them a bit. So we've just inherited that variable here, so we don't need to repeat it here, right? We don't need to repeat it. We should create our own constructors. Yes, they should be created. So public section and dog, and we need the destructor of dog. We also need the same thing for the cat and for the cow. Okay, so for the dog and for the cat, well, for the dog we need also destructor. And what? Let's assign the voice here, right? So dog is doing what? Dog is doing, for example, how, right? Let's create cat and cow a bit faster. Well, we can copy this. It will be faster. So cat, cow, okay, so we have now cow, cat and dog, and what is cat doing? Cat is saying meow, right? And cow is saying moo. Okay, so we have 3 animals right now with different voices, right? Well, we need to, of course, do that things in the public section. Okay, and now we inherited that function, right? So when I create now, for example, our dog, cat, and co, and I do something like that, everything is working fine. Default value how, meow, moo. So we just needed to create the constructor, the destructor, and we are using because of the inheritance, so it's very fast. We can use the property and the function from here. Okay, but now imagine a problem like that. I want to change that function a bit here. For example, here, here, and here. I want to change it a bit because I want to create a variable that will be called sign in the private section, like for example that. So, well, I want to change something, right, in our classes, and I will do something like sign for dog is D, sign for cat is C, and sign for cow is CO, for example. Okay, so they have now signs, so it's a bit different. And now I want to return here the voice plus that sign. Okay, so we're changing a bit how that function is working, right? We're changing it. Now when I build and run that program, everything works fine. We added that signs here easily, right? Well, we can do it that way, that way. So it works fine, but it's because we are using the right type here. But now imagine a situation like that. I would like to do a function that won't return anything, that will be called voice of animal, and I will take here as an argument animal. Exactly, I'll take here the pointer to animal, and I just want to send to the output the p get voice. I want to do it that way. Everything is compiling, so I wrote it right away. So I want to use voice of animal, and I want to send there an address. So I want to send there, for example, something like that. This thing should be easy to understand now. Well, sorry, of course here's voice of animal. As you can see, we have default value now. This is kinda easy to understand because what? Here we have an animal, the type is animal, right? And we have got now here that function get voice, and I am returning the voice here. Because pointer can point to the type animal here, and we can, by using the pointer, easily access the function, right? That's okay. But I told you that normally when we create, for example, pointer like that, and for example I create here a value like that, I won't be able to do something like that, right? Of course, we can't assign the address of double to the pointer that can store what? An address of integer. That's impossible to do here, right? But in classes it's a bit different. In classes, when we are inheriting from animal, as you can see, we are inheriting from animal, that class, cow, cat and dog, can, the addresses of that types can be assigned to the pointer of animal. So we can easily do something like that. Animal, the pointer, remember about this, the pointer, and we can assign here dog, for example. As you can see, everything works fine, even though the types are different, but it's only because the dog is what? The derived class from animal, right? So we can do it easily. Of course, let's check if I can do something like that. To dog, I want to assign the address of, for example, cow, right? Can I do something like that? As you can see, I can't do that. Well, maybe let's create first the pointer, and I want to do it that way. As you can see, we can't assign the address of cat to the pointer that is pointing to the type of dog. That cannot be done, but this thing here can be easily done. But now, what will happen when I do something like that? P, and set to the output the get voice. As you can see, now we have we have on output the how, right? So the dog voice here. And is it really the thing that we wanted to see here? Hey, well, we have here a sign also. Why did I get here only the voice? We are getting voice, but I want to see here also what? I want to see here also the sign. So by using the pointer that way, we are using the function from class here, not here. Even though we are pointing to the address of the dog. Because when we do something like that, the compiler exactly doesn't know if we create classes later that will inherit from animal. Compiler doesn't know. Well, we could just do it that way, right? It doesn't know about the classes, and because he doesn't know about it, we should inform him by using something like virtual word. And now, because we use the virtual word, we are saying, hey, when something like that saying happen, like that here, please check if there isn't a method in the inherited class, in the derived class, in the subclass, in the child class, that is like that one. Because, you know, I want to use that function, not that function here. Okay? So now when I build and run, as you can see, I have got the sign. Without the virtual word here, only that function is working here. Okay, so that virtual word is working like I told you now. And now notice what is very cool about it. I can use the voice of animal function easily, and I can send here the address of dog. I can use here the address of cow. everything works fine, it's cool. And now notice that speed, it is very fast to do things like that now. Well, later you can have, for example, arrays of cats, dogs, and cows, and you can use only one function to operate on them. Easy. That's the cool thing about the virtual thing. And notice now that, well, we know what is the virtual function, but we don't know what is the polymorphism. Well, notice that we have got here a few morphs because the dog, cat, and cow is just three different morphs, right? So this is the second part. This is the second part of that word here, right? The morph, and they are poly, so they are a few, right? Poly means a few, right? More than one. And our compiler, because of saying that word here, knows which function he should invoke, right? Which function he should invoke from here. And this thing is called polymorphism. That thing that our compiler knows which of that morph, of that few morphs, he should invoke here. Okay? That get voice here. So this is the polymorphism. And it's really, really good. I know that right now you might be like, whoa. But later everything, when you program a bit, you'll notice that these things are just very, very cool. I'd like to also show you that you can, for example, overload that thing here, and you can take a reference like that, and everything will work fine also. So now we are having a reference here, and we can send here now cow, right? And it works also fine. So we can use the reference, not the pointers. Everything will work fine also. But it's easier to send a reference here, right? Because we don't need to remember about that address here. However, sending an address like that, I think it's a bit faster. So that thing should work, should be used the most time. Okay, so now let's see what is that abstract class. I told you at the beginning that default value, that is a bit abstract, that voice for animal that doesn't exist. What should I assign here? I didn't know it exactly, right? And we can do something like that. Now we've made that class the abstract by doing something like that. But when we have an abstract class, we can create an instance of that class. However, as you can see, we can easily inherit from class like that. But now we don't need to specify things that doesn't matter, right? That thing doesn't matter. Well, we lost time to assign something to that place, that voice, because that will never be used, right? Nobody will create an animal of just nothing, right? That class is will be used only by programmer to create other classes that will inherit from that class, right? So this is just an abstract. This is an abstract class. So this thing here is telling our compiler that this class is now abstract. We can now easily inherit from that class. Okay, that's all in the lesson. Thank you very much.